What is the sum of the reciprocal of cube x and reciprocal of cube y from the given equations? Let the sum of x and y equals to 1. We call it equation 1. And the sum of cube x and cube y equals 3. We call it equation 2. From equation 1, y equals 1 minus x. Put it into equation 2. It implies that the sum of cube x and the cube of 1 minus x equals to 3. Expand bracket and we obtained equation as shown on the screen. It is because equal but opposite terms cancel out and we have that 1 minus 3 times x plus 3 times the square of x equals 3. Rearrange terms as shown on the screen. Solve for x using general formula. X equals 3 plus or minus the square root of 33 all divided by 6. We have y equals to 1 minus 3 plus or minus the square root of 33 all divided by 6. Thus, y equals 3 minus the square root of 33 all divided by 6 when x equals the sum of 3 and the square root of 33 all divided by 6. And also, y equals the sum of 3 and the square root of 33 all divided by 6 when x equals the sum of 3 and the square root of 33 all divided by 6. Any set of the solutions will satisfy the result of the given expression. Thus, the sum of the reciprocal of cube of x and the reciprocal of y equals to negative 162 divided by 16 equals negative 81 divided by 8. After simplification. Therefore, the sum of the reciprocal of cube x and the reciprocal of cube y equals to negative 81 divided by 8.
Required to find the value of the product of 100 and x divided by y from the given equations. Let x equals 8 to the exponent of the sum of 1 and log 3 to base 2 all divided by 216. We call it equation Q and y equals 4 to the exponent of the sum of 2 and log 5 to base 2. We called it equation H. This implies that 8 to the exponent of 1 equals 8 to the exponent of log 2 to base 2. Replace it in equation Q. Thus, x becomes or equals 8 to the exponent of the sum of log 2 to base 2 and log 3 to base 2 all divided by 216. By laws of logarithm, log of product of c and d equals the sum of log c and log d. It implies that x value for now equals 8 to the exponent of log of the product of 2 and 3 to base 2. All divided by 216, which equals to 8 to the exponent of log 6 to base 2. All divided by 216. But 8 equals 2 to the exponent of 3. It implies that x equals 2 to the exponent of the product of 3 and log 6 to base 2. All divided by 216, which equals to 2 to the exponent of log 6 to the exponent of 3 to base 2. All divided by 216. Where Greek e symbol is used here to be equals to the exponent of. It implies that, by laws of logarithm as shown on the screen, we have that x equals 6 to the exponent of 3 divided by 216, which equals 1 after simplification. Thus, x equals 1. We call it equation 1. Also, y equals 4 to the exponent of the sum of 2 and log 5 to base 2 from equation h. But 2 equals log 4 base 2. Replace it in the equation h. This implies that y equals 4 to the exponent of the sum of log 4 to base 2 and log 5 to base 2. By laws of logarithm, log of the product of c and d equals the sum of log c and log d. It implies that y equals 4 to the exponent of the log of product of 4 and 5 to base 2, which equals to 4 to the exponent of 20 to base 2, but 4 equals 2 to the exponent of 2. This implies that y equals 2 to the exponent of the product of 2 and log 20 to base 2, which equals to 2 raised to the power of log 20 to the exponent of 2 to base 2. By applying laws of logarithm as shown on the screen, we have that y equals 20 raised to the power of 2, which equals 400. And from equation 1, x equals 1. Therefore, the product of 100 and x, all divided by y, which equals to 1/4. After substitution and simplification of value. What are the values of y from the given exponential equation? But 9 to the power of y equals 3 to the power of 2 times y. Also, 3 to the power of the sum of y and 1 equals the product of 3 and 3 to the power of y. By laws of indices, substitute in the given equation. This implies that the sum of 27 and 3 to the power of 2 times y equals the product of 12 and 3 to the power of y. Rearrange the terms in one side of the equation. It follows that 3 to the power of 2 times y minus 12 times 3 to the power of y plus 27 equals to 0. Let 3 to the power of y equals to x. Hence, factorize the equation, and we have that the product of x minus 9 and x minus 3 equals to 0. Either x minus 9 equals 0 or x minus 3 equals 0. It implies that x equals to 9 or x equals to 3. But x equals 3 to the power of y. It signify that 3 to the power of y equals to 9, or 3 to the power of y equals to 3 to the power of 1. Simplify and we have that 3 to the power of y equals to 3 to the power of 2, or 3 to the power of y equals 3 to the power of 1. Equal base cancel out. Equate their powers. It means that y equals to 2 or y equals to 1. Therefore, y equals 1 or y equals 2.
Find the values of x in the given algebraic equation. The lowest common multiple of the left-hand side of the equation is the product of the square of x minus 2 and the square of x plus 2. Thus, multiply the numerators with the LCM and divided by the LCM. Then, equate the result to 2. Expand the numerator brackets. We obtain that expanded form of the equation as shown on the screen. Notice that denominator of the left-hand side of the equation is the difference of two squares. Replace it in terms of the product form as shown. Expand the numerator brackets. Equal but opposite sign terms cancel out. Combine like terms and simplify. Cross-multiply to obtain that the sum of x to the exponent of 4 and 4 times the square of x equals the square of the difference between the square of x and 4. Expand bracket and we have that. Also, equal but opposite sign terms cancel out. Combine like terms and simplify to give 12 times the square of x equals 16. Divide the equation by 12. We have the square of x equals 16 divided by 12, which equals to 4 divided by 3. Take the square root of the equation. It implies that x equals plus or minus 2 divided by the square root of 3, which equals plus or minus the product of 2 and the square root of 3 all divided by 3.
What is the value of the given expression? Simplify. Assigned y to be equals to x. This implies that the sum of 16 to the power of 2 times x and 32 equals the product of 12 and 16 to the power of x. Let u equals 16 to the power of x. Thus, the sum of the square of u and 32 equals 12 times u. Rearrange the terms in one side of the equation, and we have the quadratic equation shown on the screen. Factorize this quadratic equation formed. We have that the product of u minus 4 and u minus 8 equals to 0. Either u minus 4 equals 0 or u minus 8 equals to 0. Thus, u equals 4 or 8. But u is equals to 16 to the power of x, put u equals 4. So that the square of 2 equals 2 to the power of 4 times x. Equal base cancel out and we have 2 equals 4 times x. Hence, divide the equation by 4. X equals half. Recall that x equals y. Therefore, y equals half. When u is equals to 8, we have that 8 equals 16 to the power of x. 2 to the power of 3 equals to 2 to the power of 4 times x. Equal base cancel out and we have 3 equals 4 times x. Hence, divide the equation by 4. X equals to 3 divided by 4. Recall that x equals y. Thus, y equals to 3 divided by 4. Therefore, y equals to half or 3 divided by 4. From the given expression, the square root of the sum of 1 divided by y and the square root of the sum of 1 divided by y and 2. Substitute y equals to half in the given expression, and we have that. Simplify the substituted numerical expression, and we have that the square root of 4 equals 2 after simplification. Therefore, the given expression equals to 2 when y equals half. Also, substitute y equals to 3 divided by 4 in the given expression, and we have that. Simplify the substituted numerical expression, and our result equals the sum of the square root of 4 divided by 3 and the square root of 10 divided by 3. When y equals to 4 divided by 3. Therefore, the given expression equals to 2 when y equals half is the only result that is given in the options. Therefore, the correct option is C. Find the values of x in the given algebraic equation. Let u equals the square of x minus 22 all divided by 3. It implies that 5 raised to the power of u equals the sum of the square root of cube of 16 and the square root of the cube of 54 all divided by the square root of cube of 2. We call it equation 1. But the square root of cube of 16 equals the product of 2 and the square root of cube of 2 and also the square root of cube of 54 equals the product of 3 and the square root of cube of 2. Substitute the simplify forms into equation 1 and simplify further to get that the sum of the square root of cube of 16 and the square root of cube of 54 all divided by the square root of cube of 2 equals to 5. We added up the numerator, since the terms are like surds, and then performed the division operation. Substitute the numerator in equation 1. It follows that 5 to the power of u equals to 5, which equals to 5 to the power of 1. Equal base terms cancel out. Equate their powers. Hence, u equals 1. But u equals the square of x minus 22 all divided by 3. This implies that u equals the square of x minus 22 all divided by 3, which equals to 1. Cross multiply. The square of x minus 22 all divided equals 3. It follows that the square of x equals the sum of 3 and 22, which equals 25. Take the square root of the equation and we have that x equals plus or minus the square root of 25, which equals plus or minus 5. Therefore, the values of x equals plus or minus 5.